Hello, Bob Hughes here with JD Squared. In this video, we're going to talk about a feature in our rotary and bending software named Camelot that has to do with die sets and what is produced when you actually bend a piece of tubing in your bender. To illustrate this, let's open up the die library right here, and you're presented with this table here, and the table is where you would have your entries of the die sets that you own and what they produce. For instance, we have a checkbox over here in stock. You may very well have a die that you're using for design purposes, but you don't actually have the die in your possession. In that case, you would not check this in stock box, but you would over here. Now you'll see in a little while how all this ties together. But anyway, essentially, let's look at the different columns of the die library here. You've got a die description, nothing more than, describe the die. It's just a name. Then you can enter values for the physical dimensions of the material that'll handle. So for instance, round tube, 1.5" OD. No height, no width, because once again, it's round. If it was rectangular or square, you would fill these in and not fill in the OD. Wall thickness, the material, what it's made out of. And then the column here is called the achieved CLR, And what we're looking for right there is you go and you do a test bend in your bender with the material and the wall thickness, and you then measure what is the actual centerline radius of the tubing after it was bent. When you bend tubing, you'll notice that it springs out of the die when you release pressure on it, which means its centerline radius, and that's the radius if you envision going right down the middle of the tubing, is going to be a little larger than the die itself. So even though the die is 5.5 inches centerline to the middle of the groove, your achieved centerline radius of the bent piece of tubing is going to be slightly larger than that. In a lot of cases, it works out to about 1/8 inch or 3 millimeters on average. So that's what the achieved CLR means. The lead-in value right here is the distance from, if you look at your die set, you're going to see that there's a place on it like a machined edge or a saw cut, or depending on whose bender it is or whatever. Hopefully it's a JD squared bender, but you never know. It's going to be a place where you could put a mark on it, a reference mark. In our world, we refer that as the lead in, and it's basically the distance from the mark to where the tubing will actually start bending, or the tangent point of the bend. And you can measure that very easily with a ruler. That's what you would enter in the lead in column right here. The final column is your K factor. Now K factor has to do with how much will a workpiece either stretch or compress when it's bent. Now, most of the times it's going to stretch, and the way that you determine that is if you can visualize your workpiece where it's got a line right in the middle of it. So in a piece of tubing, it would be right in the middle of it. When you bend your tubing, there's going to be a certain point of a certain place in the bend where it's going to compress on the inside, and on the outside it's going to stretch. Well, that centerline radius of the part of the tubing that did not bend or did not compress or stress is called a K factor, and it's a percentage of where on the workpiece it is. So 0.5, like this one right here, would mean that the thing didn't grow or shrink in length because the K factor was right in the middle. So when you bend it, it stayed in the middle. That's never the case. It's always going to stretch a little bit when you're bending tubing or pipe. So the question is, you're probably asking, well, that's great, Bob, but how in the world am I going to determine the K factor? Well, we try to help you out here with a little K factor calculator, and the way you use it is extremely simple. You go in and you just cut off a piece of tubing. We just don't care how long it is, just cut it. But let's just say it's 24 inches. And then we're going to try 1.5" OD tubing in our bender, and we load it up in the bender. It's a 5.5 inch radius die. We just go ahead and make a bend. It doesn't matter anywhere in the middle where you make your bend, just make a 90-degree bend. Now you want it as close to 90 as possible because that will help give you a little more accurate value of a K factor, which lets the program more accurately calculate how much stretch you're going to have, and that determines how long your raw piece needs to be. Anyway, you measured and hey, it looks like it's 0.5625, and now what you're going to do is you're going to enter the length outside to inside. Just stand the thing up, measure the height. So let's just say we measured L1 and it was 12 inches tall. Okay. Now we're going to measure L2. So we measure from here to the outside. Let's just say it's 16 inches. You measured that. Hit calculate. There's your K factor right there. 0.464, and it's a little less than 0.5, so that tells you that your tubing stretched, which means you're going to need less tubing to make that bend than you would think you would. All right, so we say okay, take over the calculated values, and it brought it over to right here, and all we got to do is save it. Now we have our calculated K factor, we have our lead in. If we didn't like this lead in, let's just say we measured it, it's really 0.75, that's fine, save it. Now you have this entry. Now another situation is you just got another piece of tubing. It's 188 wall, inch and a half or something like that, and you want to enter a new one. Just go ahead and select another one of, select one of your bends or whatever. Come along, put in a new wall thickness. Let's just say it's 180 thou. Lead in is going to be the same because that usually will never change on a given die set because it's basically machined into the features of the die, but the chief centerline radius may. Now, being a heavier material, and this for this we're going to say it's mild steel, okay, or you could say heck DOM whatever, over here on the chief centerline radius, let's say you measure it and it's actually larger. It's 5.75 of it, or let's just say 6 inches. What the hell? You do that, and then once again you do your K factor calculator. You get your piece of tubing. We'll say 24 inches. Notice the centerline radius is what you entered over here now, and you enter line 12 and 16. Let's calculate it. We have a bended calculated K factor of 0.532, which in the real world probably is not going to happen. It would probably be less. Let's change this to 0.65. Calculate it. There you go. There's a K factor of 0.32. I was looking for something under 0.5 because tubing always stretches. So 0.32. Okay, let's take that value over. Now we just add it, and there's your new die right there. So whenever you're going to bend that material, this is how you're going to use it in our frame editor, and that's the subject of another video. And it's also going to be used in all of the computer and the software's calculations of how to bend your tubing. Now, one other feature right here. In our software, we have a thing called the active die set. And what it is if you could imagine working with your geometry, creating your geometry or whatever, you're going to be limited to what your capabilities of your bender are. So if you load in a piece of roll bar or something like that the radiuses don't match what you have, you're going to have to change that radius to what you do have in the model so that you can do it. And the way we did this is we try to simplify it as much as possible, and I hit upon the idea of the active die. So no matter what die you select here, you can make that the active die. And let's just do that. So for this particular DOM one with a 6-inch radius, we're going to make it the act. You know what? So that it's a little more visible, let's go ahead and change that to a 7-inch radius. This is just for demonstration purposes so you'll see it clear. We are now going to close this window and make this the selected die. If we just close it over here, we have not changed the selected die, but we're going to select it. All right, now let's go and see how does this play out in the long run. Let's go ahead and bring it apart, and we're going to bring in a simple roll bar. Now this roll bar was created in another program. It could be Fusion 360, Onshape, SolidWorks, or it could be created in our own frame editor. But it's just a simple roll bar. Now it's asking, do we want to detect features? I think other videos explain what that is. We're going to say okay. It's basically looking for any miters, holes, bends, etc. In this case, we do not want to make a job for it because jobs are defined as operations done on a piece, a work piece, that do not involve bending, because you'll see why in a second. Anyway, here we go. We got a roll bar right here. It knows that it's a roll bar. You know, it knows that it's a round tube at this point. And over here, if you look, you notice that all the dies are the same radius. So if you look at all the radius in this particular workpiece, they're all the same radius. Our program is telling you that. It's also telling you that this is the length, 82.585 long and all, for this radius here, right? And you do not have that die right here. You do not have that die in stock, so therefore you cannot actually produce this part the way it's modeled right here. So how do we fix that? We're going to go and right click on the part, and we are going to edit with our frame editor. Okay, at this point there is that part right there. Now remember, I talked about the active die set, right? We could go over here and we could select an active die, you know, anyone we want, close and make the die active, and it's telling you what the active die is. It's saying that your die is going to give you a 7-inch achieved centerline radius. Tells you the wall thickness, the whole bit, you know. It even tells you if you got the die in stock, the die that you selected. All right, so it's the active die and you can't bend this part yet. How do we change it? This is really cool. You're gonna love this. Click right here on the bend. Notice now that is your active die. It's showing you this is the model die, this is the active die. If we apply the active die to the selected bends, there's your, I'll go ahead and update, there's your new part. That's what you're going to be able to produce in your thing, right? So let's go back over to it, but this time here we're going to want to do all of the bends. I'm not going to, you know, if I got a piece of work piece with 8 bends, I'm not going to want to select the individual ones. You just click on any straight line and it will highlight all the bends and show you what they will look like with the active die. Once again, we apply it, we save it. Now notice the different radius bends there. Anyway, that is the principle of the active die, the die library, how you can make our software compatible with what your tube bender does. That's basically the gist of it right there. Now to close out real quick, I'm going to do one thing more. I am going to go ahead and this, even though this is a subject of another video, we are going to go ahead and bend it. It's actually telling us everything about the material over here, the center line radius, what the material is, the whole doggone bit. And we're just going to go ahead. Now if we go to dimensions, by the way, dimensions will tell you the length. You know, we've got 80 inches of tubing we're going to need. Here's your bands for your lead in, where to put everything, all that. But if we just go back over to the animation view, at this point we can actually start the bending process, and we'll animate the bends for you. And this, once again, this is the subject of another video. I just wanted to show you that clearly the new bend that we have applied has been applied to the model. Anyway, I hope this video has been a help to you, and thank you for watching, and have a great day. Bye.